already indicated that we have a recording of this session, so I have just enabled the recording. Sayan, I think we can go ahead. The people, whenever they have time, and they can watch the videos. Those guys who have been late, or who couldn't attend. For the benefit of time, I think we can start the session here. Okay.
Okay, that's right. I think that's a good idea. Of
Yeah.
course, we can do
Right.
that. Yes.
Yeah.
Okay, perfect. Yeah. So we actually had Mr. Surya who joined and then he left. So
No, he
maybe
will
we.
be.
Oh, yeah, Mr. Yeah, here.
He's
Yeah, yeah.
there.
Hi,
Yeah.
Surya. Yeah, yeah.
Yeah, hi,
We
hi,
were
Mr.
just
Saini.
doing
Hi,
a
sir.
small introduction with everybody. So you want to also quickly introduce yourself
Yes,
for the rest of the folks?
I'm
Yeah.
sorry. Today is also working day for me, so there are other meetings, the calls that I've received, so I have to end the call and rejoin. Are you able to hear me?
Yeah. Yeah. You are able to hear.
Okay, okay. Yeah, so I'm Surya from Hyderabad. I have I worked in different industries like healthcare, retail, and service industries in the operations role, right? My last thing was at a medtech company. I was managing the program for this Medtronic, I mean the company, the last medtech company across Asia Pacific. So I have 18 years of experience. I don't have any tech background, but I have a strong inclination towards learning technology. Were you able to hear me?
Yes, yes, Mr. Surya. We can. We
Yeah,
can.
that's pretty much
Yeah,
from my side. I
we
think.
can.
Yeah.
Okay. Okay. All right. All right. That's great. Thank you. Thank you for your introduction. Thank you for your introduction. And again, great to have all of you in this meeting. And today is our very first session. So, and I just wanted to like once again thank all of you for being a part of this cohort. I'm sure like we're going to be doing things very differently. Uh, and this is obviously, I think, as has already been conveyed, not a regular course. So it's not something where we come with uh, like exercises and quizzes and all that. So we're going to be doing things very differently, very practically, and the objective will be a lot of real world learning. So that's what we are really trying to accomplish, so that you're able to actually implement things. And I will clarify the general agenda of what we will be doing and how we will be pacing things out. And as I said, because we are a very small group, we're going to keep things very open. And I'm also very flexible to add and remove content the way you want. So we want to really make it aligned to how you want to learn. So there's a general structure that we will follow. But obviously, let's say there'll be some topics that some people want to learn. There's some things that you want to do. There's some things that you want to learn more on. I'm very open to that. So those are again things that we will be incorporating here. So that's why it's going to be very different from how generally courses happen. Okay. So very broadly, today we will have a very short introductory session where the objective would be to clarify the different jargons and the different terminologies in the world of AI. That is primarily what I intend to do today. Okay. Um, Many of you, I think around 60 to 70% of you are fairly well versed with supervised learning, unsupervised learning, the terminologies here. But at the same time, we have participants who are totally new to this space. And what we want to do, at least in the first few sessions, is to create that level playing field so that everybody is basically at the same level. So that is generally what we will do. I'll start out with AI. I'll start out with what is machine learning from a technical perspective. We tend to hear lots of examples of ML, but we'll try to understand today exactly what machine learning is from a technical perspective. What is ML? What is supervised learning? What is regression? What is classification? What is unsupervised learning? What is reinforcement learning? What is this thing called generative AI coming from? So these are all the different terminologies and jargons that we will try to clarify today. Okay. Generally, the sessions will go on till 2 hours. Just to set the expectations, we can maybe some days might be 2.5, but we'll try to cap it off at maximum 2.5 to 3 hours maximum, and we'll try to consistently meet over the weekends. Again, the schedules might vary a little, but at least at a Saturday, Sunday, we can follow a fixed schedule. I think this is also important. I think the discipline part is also important. So once we have a rhythm in place, I think things work out a lot better. So the Saturday, Sunday definitely we'll be doing, because most of you are at home. It's usually a holiday, and we will try to set up a rhythm on Saturday, Sunday around the morning time, around this time, or maybe at 11 we can start, 10:30, 11 we can start. And then on certain weekdays, we can do evening times. So that again will be conveyed to you. Evening or morning times we will do. Okay. And that will be conveyed to you. Okay. And we will discuss that later. Okay. All right. So now a very short introduction about myself. I think the team already did go ahead and maybe share a small intro about myself. So here is what I do and what I'm involved. Let me just share my screen. Just give me 1 second. My screen is not shared. Just give me 1 second, guys. Let me just share my screen actually. Okay, here it is. I think all of you can see. So this is myself. This is Mr. Shayan here. And once again, great to meet all of you. So this is my profile of what I do and what I'm involved in. So I am presently in Qatar. So I'm taking the session, I'm presently based out of Qatar, and I work on a small contracting position there with the government. And I have a small consultancy firm in India also, through which I do some startup work in AI and machine learning. I keep traveling a little, so India and Doha generally I keep traveling, but presently I am taking the session from here. Apart from that, I have around 15 years of industry experience. I have pretty much started my career from data engineering, uh, worked on things like MSBI, SQL Server integration services, reporting services, worked extensively on databases, data warehouses. So that is where I started from, right from the data side of things. Okay. And then from there, I gradually, around 2014, 15, I got my first project in Infosys. That's what really exposed me to the beautiful world of data science. And that's what really interested me in data science. So I would say officially I started my core AI ML work from 2014, maybe end of 2013, you can say. And that's when I really, started on. I've changed 4 companies in my career. Went on to become a senior manager for WNS Analytics practice. And then from 2018, beginning of that, I have been pretty much working independently in various consulting positions. Uh, and also, mostly I've been operating my own, a consultancy through which I do a lot of corporate trainings, like the ones that we are doing with you guys. So I do a lot of corporate trainings, and I do a lot of general consultancy work for different startups. And I think 2018-19 was really like the absolute, I would say, uh, maybe the crazy times of AI and machine learning. A lot of people wanted to learn. So the same trend that you're seeing in generative AI today, everybody is looking to learn Gen AI. I would say around 2018, 2017 was where we saw that trend in AI and machine learning, right? So machine learning is a lot more, a lot more stable. It's a lot more mature in enterprises today. Although it's a little new to many of you, I understand. But if you look at the enterprise context, it's very mature. It's not exactly new. But yes, I mean, 2018, 19 were like the absolute crazy days. So the same thing that you're seeing in Gen AI today, maybe 18, 19 is when everybody wanted to learn, machine learning, supervised learning, and all of those the algorithms and all these things that we will talk about. Okay. And yeah, so that's pretty much what it's been for the last 6 years. And very recently, I joined this position with in Qatar. It's been around a year, and I do some work on large language models for them, mostly on the LLM space. And that's pretty much my area of work. So again, it's a defense thing. I won't be talking too much about it, but I'll give you some general applications as we go along through the course. Okay. Okay. So this is what my background is. And now, without any further ado, let's start on and let's jump right into the actual contents. Okay, I'll be sharing a lot of contents and materials with you. And usually, what I will do is I will have a Google Drive where I'll be usually keeping all my materials and all my resources, and I will make it a point to share all these, through the Google Drive link with you. Okay, so I'll do that. I'll do this. I'll follow this practice generally, after every 2-3 sessions like this. Okay, yeah. All right. So friends, what is AI? When we think of the term AI, when we think of the term artificial intelligence, what is the meaning of the term AI? Okay. And again, another very important thumb rule I follow in my classes is uh, you have to be responsive. I think because if you sleep, I will sleep. It's a very simple thumb rule. Of course, I will not let you sleep. I think that's part of where as a group, again, as I said, we are all trying to learn, and I think I'll really encourage everybody to be participative. There are no wrong answers. When we are all learning, we all, like, even I learned these things at some point in time in my life. I made lots of mistakes then, so it's absolutely fine. Don't hesitate what other people will think. And that's why I say this is not a regular course. It's, we are all amongst friends. We are all trying to help each other. And the objective is the final outcome where you really are able to, from a career perspective, are able to transform. So don't think of making mistakes. Don't think of asking the wrong questions. Don't think about that, hey, am I asking the right things? What if I ask a stupid question? What if I say something wrong? So don't think about that. You're in a very safe space among a very small group. Okay. All right. So what is AI? What does the term AI actually mean? Anybody wants to start on? Who would like to start? We have quite a few people who already have studied this. So anybody wants to? What is your thoughts about AI? What does the term AI even mean? Who will go? Dhruv, you want to start?
Yes, so I think AI as its evolution of artificial intelligence. So they, the computer or the software are trying to mimic what decision making of a human is. So that's what I think AI is.
Brilliant, brilliant. It's basically a machine or some computer or a software trying to mimic the human brain. It's basically where a machine is trying to do, think and act the way humans do. And that's where the term artificial intelligence was first coined. The term AI was first coined back in the 1950s. And in 1950s, in the Dartmouth College, there was a summer conference that happened. The year was 1950s. 1950s was a time when, you know, uh, lot of things that we take for granted today, none of these things were there. Things, you think of it like, we did not have personal computers back then. Uh, we didn't have programming languages back then. Boolean algebra was just starting to come up. Okay, so a lot of the things were new around that time. Okay, so the term AI was a very new idea and very new concept around that time. Where how do we how do we make machines, think and act the way humans do? It was a very fascinating idea for researchers, and the kind of AI that really flourished around that time was what we refer to as rule-based AI. Another term that we use for it is called expert systems. So these are like pre-programmed devices. It's like what we call pre-programmed devices. So it's like you have a device and you pre-program it, you give it some static instructions, and you tell the machine what to do and how to do it, and the machine does it for you. So that is what we refer to as rule-based AI. I'll give you a very simple example, friends, to help you relate to it and understand it, even better. So let's understand what exactly a rule-based AI even refers to, right? So excuse me, what exactly um, what exactly is rule-based AI? So think of a small air conditioner that is running in your room right now. Okay, maybe you can think of it like an AC cum heater because it's winter in the country, right? So um, imagine you're an AC in your room and the AC is running at 27 degrees Celsius, right? So what do you think will happen, friends? So if your AC temperature is set to 24 degrees Celsius, the AC will automatically control the temperature to be 24 degrees Celsius. Think about it. Whenever your outside temperature goes above 24, the AC will continue cooling. Have you heard that sometimes the outside unit, the fan will rev very fast, and whenever the ambient temperature, the room temperature is going below 24, have you observed that the outside unit shuts off? The fan actually stops rotating. Now, when you think about it, what is it? Now we can always say that there is a kind of a sensor that is guiding exactly how the AC is functioning, and the sensor is deciding how the AC will operate. And it is almost like a simple if-else statement, isn't it? So if the room temperature is greater than 24, do this. Else, if the room temperature is less than 24, do this. It is like a simple, a kind of a rule-based thing that we are looking at. If it is more than 24, do this. Else, if it is less than 24, do this. That's the way how we are able to understand the idea behind what rule-based AI is. Okay, so it is almost like the manufacturers of the AC, be it a Samsung, be it a Panasonic, be it a Voltas, the manufacturers of the AC have hard-coded the instruction. That's why I said you provide the rules. They have hard-coded the instructions. They've explicitly stated what the AC will do, how the AC will function, and the AC is just following exactly what you asked it to do. That's it. But if you think about it from a third person's perspective, isn't it incredible, guys? I know we take these things for granted. The climate control system inside a car. You set your climate control to 25 degrees Celsius, and isn't it incredible that it's able to maintain 25 degrees Celsius automatically without human intervention? That's AI. I'm starting with the simplest ideas. AI doesn't have to be something exceptionally fancy. No, let's start with something very simple. How did the ideas evolve? Where did we start from? This is AI, isn't it? It is artificial intelligence. That means there is some intelligent system that is able to monitor what is your ambient temperature, and depending on your ambient temperature, that intelligent being is able to automatically adjust the functioning of the air conditioner. I'll give you one more example. Think about again, it's something that we use every day in households, like washing machines, especially the fully automatic ones. What do you do there? You turn on your washing machine, you press the button, you set a particular mode, and when you press monsoon mode, everything is pre-programmed. Have you observed? Every single aspect of the washing machine is pre-programmed. How much of water to add, how much of rinse cycle, how much of wash cycle. Even sometimes before the washing machine starts with the normal operation, you will see the first 5-10 seconds it will take to uh, automatically adjust the time. Have you observed that? It'll try to understand the weight of the clothes that you put in, and in the more modern washing machines, they will even look at the cloth density. They have a lot of algorithms that are built in to figure out how much of clothes and what is the density of clothes that you have, not just the weight. And based on that, although there are some preset modes that we'll be using, but they will automatically adjust the timing. Now, these are again wonderful applications of rule-based intelligence. Now, if you think of it from a third person's perspective, well, who is monitoring? Who is deciding how much of water to add, how much of detergent to add, how much of conditioner to add? Who is deciding that? Who is responsible for making that decision? Well, nobody. It's pre-programmed. The manufacturers of the washing machines have already pre-programmed it. So that is rule-based. But it is still intelligence, isn't it? You press a button and something magically happens without any human intervention, and that is what we refer to as AI at its most rudimentary level. So some intelligent being is able to figure out what to do and how to do it. That's the idea of rule-based AI. I'll give you some more examples to help you relate to this idea a little better, friends. Okay. I have my mobile phone with me right now. Now, if you look at a mobile phone, this is a Samsung phone and I have an Android OS. Now, if my mobile phone goes below 15% battery, something very interesting will happen. Okay. So if my mobile phone goes below 15% battery, something very interesting will happen. So what will happen is my battery saver mode will turn on, my screen will dim, and if I try to go to my camera and try to access the camera flash, it will not work. Now, these are some incredible things that will always happen whenever your phone goes below 15% battery saver mode. Have you also observed if you're using a 5G phone, maybe if you're using a Geo True 5G or something of that sort, 5G downgrades to 4G. Have you seen that? In battery saver mode, you never get 5G. Now, these are incredible things, isn't it? Like we use these things day in, day out. We take these things for granted, but think about it, friend. Isn't that AI? Now, when you think from a third person's perspective, some intelligent being is able to monitor that, hey, here's a phone going below 15% battery. So I need to turn off 5G. Somebody is able to figure it out without any human intervention. It's not as if you're going to the phone and you're making it 4G. No, you can't. You cannot do that actually. You cannot do that. These are some restricted operations. Unless you change your APN operators and all, you cannot directly do that. But well, it is built into the operating system. It is hard coded. It's codified. So think of it like the manufacturers of the operating system. The at the OS level, they've already written some code, some kind of an if-else statement where they've specified that if this happens, then we will do this, else we will do this, else we will do this, and the machine is simply working as per that. Smartphones also have this wonderful feature of, you know, uh, thermal shutdown. Have you seen? Like the summers will come next year, and you can try it out. Maybe even now you can. Maybe the heat intensity will be very less, but you can still try it out. Take your phone, keep it under the sun for a long time. Maybe half an hour you can try. Take your smartphone, keep it under the sun for half an hour, and after it gets sufficiently hot, you will get an automatic message saying thermal shutdown. All the modern phones have this feature. Incredible, isn't it? Like if you're making a phone around that time, the phone will automatically disconnect. And it happens in cars actually. If you're using Google Maps in car, sometimes if you're not having the AC on, the car inside can get very hot. And if you're using Google Maps application or some other application and making a call, it will automatically disconnect and the phone screen will show a message saying allow the phone to cool down. I don't know how many of you have seen that this feature works in laptops also. Laptops also have this feature called thermal shutdown. So there are built-in pre-programmed instructions that are written at an OS level, at an operating system level, be it a laptop or be it a smartphone, which prevent certain things from happening. It is like if the temperature exceeds a certain value, then we will do this, else we will do this. So think of it that way. And all the major laptop manufacturers or all this, they all have these internal ways of monitoring the PC temperature. And I think these are very modern, very obvious features nowadays. Okay, so yeah, I mean, you can see I've opened up my Asus laptop. This is the one that I use right now, ZenBook Duo, and you can see that it is monitoring my CPU temperature. Can you see? So these are all sensors that are built into the laptop, and this is all happening at an operating system level. The operating system is what is controlling all these things. And if my temperature on the laptop goes beyond a particular value, okay, it will automatically go and say that okay, it's too hot, so it will automatically turn off. Sometimes you will see that when you're playing a game. Okay, many of you might be playing games, right? So sometimes when you're playing a game, excuse me, you will see the fans will typically rev much faster. See, right now I've got two fans. So this is my fan profile right now, and you can see this is the CPU fan, this is the GPU fan, and these are all controlled at an OS level. Now, when you think about the laptop itself, it is an incredible application of artificial intelligence. Now, we don't have to go too far into self-driving cars and all the stuff that we hear nowadays. Personal computers have been there for decades. Even the simplest personal computer, which I remember buying my first computer back in 2000s, around 2004, 2005, when I bought a normal Windows PC. We had these features even then. Simple rule-based instructions which dictate exactly what to do and how to do. So if you're opening a very complex program, or if you're opening a heavy application that is utilizing a lot of memory, you will see that typically the fan speed will rev much faster. Or sometimes you will see that programs go to not responding mode. Have you wondered why? Have you wondered why? Why does my application go to not responding mode? The application goes to not responding mode because there is not enough RAM available, and the operating system of your laptop is preventing you from opening that application because it wants to make the critical functions of your laptop still running. Because the critical functions of your laptop is Windows, isn't it? Windows is the most critical function of your laptop. Windows cannot stop. Other things, your game and all, they might go to not responding. Fine. Your Microsoft Excel, Microsoft Word, Media Player, Google Chrome browser, all that can go to not responding. We don't care, but Windows cannot stop. If Windows stops, everything crashes, right? So these are again important things you have to understand. Like these are things that like we use on a day-to-day basis, day in, day out, and these are excellent examples of artificial intelligence because it's almost like without any human intervention, people know what to do. It's almost like somebody's instructed this machine to do things in a certain way. Okay, I'll give you one more example. I'll give you one more example of of the modern day automobile. You sit inside your car and you wear your seat belt. If you do not wear your seat belt, have you seen the beep alarm will go on? Beep 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 beep. Have you observed that? Well, that's again a rule-based intelligence. So there are sensors which are built into the seat belt of the car, and if you're not wearing a seat belt, it will automatically trigger a seat belt alarm. Okay, so if it does not detect a seat belt, alarm will go off. Else, nothing. Same applies for automatic wipers. Whenever it detects water or on the windshield, the wipers will automatically go on, or for that matter, automatic headlights. Now, these are not some rocket science. Car manufacturers will have n number of marketing slogans to fool us, but you guys know better. There is nothing smart and nothing too great about it. It's just a simple sensor. That's it. These kinds of sensors are there in solar lights also. Have you seen solar lights? You get it in Amazon for 200 rupees per piece. 200 rupees per piece in Amazon it is available. That's a simple concept it is based on, right? You keep it under the sun, the batteries, rechargeable batteries are getting charged, and the moment the light intensity falls below a certain level, the lights automatically come on. Simple, straightforward. And that is the same idea based on which um, your automatic headlights are also working. But hey, from a third person's perspective, isn't that intelligence? Don't you think there is some amount of intelligence built in? There is some amount of basic intelligence still built in. Think of it like a simple if-else statement, right? So if this, then we will do this, else we will do this. Think about it. Or even for that matter, your airbags. How do you think airbags are? They're pre-programmed devices, right? The manufacturers of your airbags, SRS is a major company that is, that is into airbags, right? I hope everybody has heard of it. SRS, okay? SRS. So if you look at airbags are also a very very good, you know, uh, a very very good application of rule-based intelligence. So you explicitly tell the machine what to do and how to do it, and the machine does it for you. Okay, so these are just to give you an idea to you in terms of what broadly artificial intelligence refers to, so that everybody has a very clear picture. Now, what about the factory robots? You might have seen a lot of these factory robots. Let me bring this up, so I think you'll get a clear picture once you see the example. So we have had the industrial revolution for a long time. Like we have these instances of factory robots that we have here. What do you think they are? Now, again, I'm not talking about the more modern day robots like Fanuc, and they are doing a lot of other cutting edge stuff. I'm talking about general factory robots, what you see in, excuse me, manufacturing hubs around the world. And this is helping you with everyday things, every day. Even the simple water bottle that I'm using right now in my room, even this water bottle is actually being manufactured by a robotic arm. There is some kind of a device that is actually automatically, shaping the bottle the way it is, not made by hand, obviously. What do you think that is? Isn't that intelligence, guys? Isn't that incredible that there is some kind of intelligence that is able to automatically assemble different parts of the car, you know, in a sequential way? There's some robotic arm that is taking care of the windshield, something's taking care of the chassis, are taking care of the tires, taking care of the inside entertainment system. Isn't that incredible? So this is pre-programmed, precision programmed, or even for that matter, surgical devices. You see, excuse me, a lot of doctors are using surgical arms nowadays, right? So surgical arms, you can Google out, surgical arms, how they look, right? So surgical arms are used by doctors extensively nowadays for surgeries. You go to a dentist. Dentists are also using surgical devices for treatment. Now, what is that? It is controlled by a doctor. It is not as if this machine is figuring out by itself what to do. I think the day that happens, nobody will go to a doctor. At least, I mean, I don't think we have that confidence yet today. But yes, we still have these kinds of devices extensively used in hospitals. But what are these robotic arms? These robotic arms are rule-based AI devices. They are intelligent devices, yes. But remember that intelligence has been precision programmed. Precision programmed. So you press a button and it knows exactly what to do precision programmed under the supervision of a doctor. And that is a very, very important idea to have. It's not as if um, the surgical arm is thinking for itself what to do. That is the completely AGI or general intelligence that the world is moving towards. Well, unfortunately, we are not there yet. We're not there yet. So when you look at this kind of a use case in next time, like a robotic arm or a surgical arm, yes, it is artificial intelligence, but it is more of like a rule-based form of artificial intelligence. Another term that we use for it, let me bring up my chat. Dhruv, I'll just come back to you in a moment. Where is the chat? Um, 1 second. Is there a chat here? I think there should be a chat. 1 second. Guys, do you see a chat option, or is that like the participants also? Like you guys see a chat option?
In call message option.
What's that?
In call message option.
Is that there? 1 second. Let me just see. Oh, there is a. Oh, but there is no participant chat, I guess, huh? Okay. Um. 1 second. I mean. No, I think there is no chat actually. No, there is no chat option actually. Yeah. Now it's there. Sorry, I think for some reason it was not visible. Yeah, now it's fine. Yeah, thank you. Yeah, perfect. Yeah, now I can see. Can you just ping me once again? I think for some reason it's going away the screen. Just ping me once again on chat. Uh, oh yeah, thank you so much. Yeah, great. Yeah, I don't know why this actually comes fine, but not sure. Yeah, okay. Anyway, so the term that I wanted to use here is called export systems. This is the other terminology that you can that we can that we can use. Export systems is what we used to call it. Okay. So these are all applications of what we refer to as rule-based intelligence, where it is precision programmed. And in fact, software, a lot of you in this audience, when you introduced yourself, you mentioned that you are all into software development, and a lot of you have done programming. So the next time when you write a computer program using C, Java, C++, Python, anything, do you do full stack development or create a website or application or whatever you do? I would say even that is an example of rule-based intelligence. Next time you create a company website or a company web application, next time you build an application, what are you actually doing? What are you actually doing behind the scenes when you're building an application? You're actually explicitly collecting the requirements. You are trying to understand what you're trying to achieve, and then you explicitly write the code. You tell the machine explicitly what to do and how to do it, and the machine does it for you. So that's the way we understand the idea of what rule-based AI is. Okay, so even the process of creating software, even the process of writing code, that is what we refer to as rule-based AI. It is AI, but not machine learning. It's intelligence because you're explicitly hard coding the instructions in the machine, and you're making the machine think and act in a certain way, the way you want it, right? So next time you open up a company website like LinkedIn is a website, right? So uh, have you wondered this? Have you wondered how does LinkedIn create this logo? All of you, I'm sure most of you in this audience, you probably know this. Like when you go to any website and when you click on inspect, right click on the web page and click on inspect, you can actually see the source code. The source code is in HTML, right? So the HTML is basically the language of the web. Any website, any web application that you see is ultimately the backend code is all HTML. So that means next time when you look at this object, so if I just go and select this particular element on the page, this particular logo. What is this? Look at it, it's an SVG object. It's an SVG, not an object, it's basically a markup element, right? That is what it is. Can you see that? So this is where it is taken from. This is where it is taken from. And if you expand it, you can actually see the exact path, what it is. Okay, so this is hard coded. Somebody had to explicitly state that, hey, I want this logo exactly here with this exact color, with this exact width and height. And that is how this is appearing in the page. And also, furthermore, you're giving a hyperlink. Can you see that? You're giving a hyperlink. So for example, if I click on this page, okay, so if I just go and come to this object, can you see this hyperlink? Look at this one. This is cyan day. So I have a hyperlink here, and this is called a hyperlink ahref. Again, I won't get too much into HTML in this class, but what I'm saying is every single aspect of the web page is controlled. Okay, so this is a hyperlink href. Href is a reference object. That means if I click on anywhere on the box, it will automatically take me there. So who is deciding that? Who is deciding that, hey, if I click on this particular part of the website, it is going to take me to science profile. It's going to take me to science profile. Incredible, isn't it? Like, isn't that intelligence? It is, right? So somehow the application knows what to do. If you click somewhere, it knows what to do. If you click on this, it knows what to do. So how is it figuring it out? Well, it has been pre-programmed. That's the way to look at it. Okay. All right. All right. Okay, guys. So this is what it is. I hope everybody's aligned. Everybody understands. Dhruv, yes, I'll take up your question, and then from here we'll move on to what is machine learning. Okay. Yeah. Dhruv, you want to ask something? Yeah.
No,
Your audio is really bad. Your audio is really bad. There's a lot of static, actually. Is it because of the headset? Now it's maybe turn off your headset. Maybe this is better. This is better.
Okay, so I was just trying to share one of my project I did in my pre-final year. I think that's an application for like the rule-based intelligence. I have posted a video on YouTube. If you want to see it, you can just search over it.
Where did you post?
On YouTube. You can search my name and you can find it.
Okay. All right. Sure. Fair enough. But you can ping on chat. Let's see.
Yeah,
I mean,
sure.
that will be.
Yeah,
you can ping on chat. Yeah. Sure. Of course. The moral of the lesson here is based on what we have studied. Next time anybody is building any application using C, Java, Python, or even you're writing a script, we have so many testers, writing test scripts and all that. Next time you're doing any of that work, well, technically they are AI engineers, isn't it? Again, I mean, if we purely look at the terminology from a terminology perspective, you are building an AI system. Even if you're a tester writing a test script, you are actually building an intelligent machine which is able to automatically evaluate those test cases, isn't it? So that's one way to look at it. So any form of software development technically is still largely a part of AI. Yeah. Anyway, so thank you, Dhruv, for sharing that. So Dhruv has shared a wonderful video. Let's see what it is. Object detection is not going to fall into rule-based AI, but that's let's see. That's more of ML-based AI. I'll talk about it, but that's not rule-based AI actually.
So actually,
Okay,
in this the rule is about the electronics part. So it only clicks the picture if the object is in the range.
Let's see. One second. Let me see what human detected.
So that's the backend part. The initial part was when an object or a human is in certain range of it, then only it clicks the picture. That's that part I was talking about. If it's the rule-based part.
And I'm curious, how are you tracking that? Are you using some kind of how are you measuring that distance? I'm just curious. Are you looking at the picture
So
and trying to estimate the distance?
It's an ultrasonic detector. So it just says like it gives out ultrasonic waves and take the repeated waves and calculated the time for it, and that's how it detects the distance of the object.
Yeah, now I get it. Excellent example of rule-based. Correct. It's like a sensor-based. Correct. You're right. Absolutely. So based on the distance, it's able to figure out. Correct. And in fact, the same idea happens for, again, not the same idea, but even in offices, motion detector-based, lighting. So if you're in the office, the lights will automatically, they're always on. And when you're not in the bay, the lights will automatically go off. So what is that? It's motion detectors, motion detectors, fire sensors, any kind of sensors that we see. this entire thing called smart devices, like all these smart devices, like smart coffee makers and smart alarms or smart cameras. Well, there's actually nothing smart about it, like uh, what is smart? It's just a simple rule-based programming, something we've been doing for decades. There's actually nothing smart about it. It's more of a marketing slogan where I guess companies are, kind of
So, like IoT
milking
would
the
fall
AI.
into this section now.
Very much, very much. I would say a large part of IoT devices that we see, a large portion of IoT devices are simple rule-based agents. That's it, straightforward rule-based codified agents. A lot of machine learning is coming. I'm not saying it's not coming, but if you look at the mass market consumer devices, most of them today they are rule-based. Like people are claiming AI because a large part of it is making a fool of customers. That's what it is because most customers don't understand it. But now that we do, now that you and I we do, we know what it is. Like for example, Nescafe. Nescafe has this thing called smart coffee maker.
Yeah.
I don't know. You tell me what is smart about it. There's nothing smart about it. All you do is you set a timer. You say, hey, tomorrow 8 a.m. You set it's like an alarm clock, right? You set a timer of 8 a.m. and at exactly 8 a.m. the device will turn on. It will add the requisite amount of sugar, milk, and make the coffee for you. You tell me what is smart about it. It's I don't know. So and they market it as AI based coffee maker. You go to Amazon. I think you get it now also, right? I think it's available now also. So smart, and they sell it for 5,000 rupees. Huh? Look at this. Look at this. This is what it is, huh? Nescafe e-coffee maker for cafe-like froth coffee. And so, and if you go to the Amazon this thing, they will go ahead and also I think they will have some marketing things which are very normal. They will say that okay, we are you know yeah, look at this 5,000 rupees, and this is AI based. You'll see that AI based thing quite a lot, like alarm based system. But the idea is, I think the idea is more like even in a company cafeteria. If you look at a company cafeteria also, and if you look at a coffee machine, you press a button, something happens. You press another button, something happens. Like it's pre-programmed. Cappuccino will come in a certain way. Espresso will come in a certain way. So this is all pre-programmed devices. That's one way to look at it. Yeah. So I think this understanding is very very important. What is rule based and what exactly is machine learning based AI? And just to put it in a more formal way, there was a person named Arthur Samuel. He was a foremost AI researcher in this space. And Arthur Samuel actually defined, rule-based intelligence in this manner. It is the field of study that gives computers the ability to learn without being explicitly programmed. And this is pretty much what we talked about on the left-hand side all this while, right? So, and this is something that has been there for a long, long time. It's a field of study that gives computers the ability to learn without explicitly programming them. I'll not tell them explicitly what to do, but they are still able to learn. And that is pretty much what we are getting towards. All this while we discussed about explicit programming. Now we will come and talk about this, exactly how this happens. So all this while it was more about explicitly writing the instructions, explicitly stating the machine what to do and how to do it. That's how we are able to build very complex systems, which we talked about, right? The modern day automobiles, the computers, the smartphones, and a whole lot of other things we are able to achieve using classical rule-based programming. But hey, how can we build things without explicitly programming? Without explicitly programming, that's what machine learning is. That's what we are entering into, right? So, friends, what I want to do is let's start with a simple example. Okay, and I think the best way to learn is always from examples. I want to take you to my Google Photos for a moment, and this is actually a fascinating, application which will help you relate to what we talked about so far and what we are getting towards. I'm searching for elephants, right? Think about it. How do you identify elephants in a picture? The same way in Google, you can actually type elephants, and Google is able to automatically bring out all these examples of elephants in front of you, right? So we type elephant, and Google is able to recognize elephants in front of you. So how are you able to do this? How can we do this? Can we write a set of rules, or can we write a explicit set of rules to make it happen? Very difficult. Okay, let me show you another example here. Now, possibly you can. I'm not completely saying that you cannot write a rule to identify elephants. But if I ask you to write a set of if-else statements to identify this elephant on the screen, can you do that? Very hard. It will be very difficult to identify explicitly this elephant, right? Of course, you can say that if I see 4 legs, 2 tusks, 2 eyes, 2 ears, big body, dark color, then elephant, else not elephant. You can, of course, write a series of if-else statements. But remember, friends, elephants can come in many, many different shapes and sizes. Now, there's an elephant in the background. Now, we cannot exactly make out the eye. We cannot exactly make out the tail. Look at this guy. We cannot make out 4 legs. And look at this guy here. We cannot even make out anything. We can make out nothing of this elephant, right? And look at this young guy here. Now, elephants have tusk. Tusk is such a defining feature of an elephant, right? But look at this elephant here. Like, if I explicitly write a rule that if I see a tusk, then elephant, else not elephant, like, this is fine, but this is not fine. You will be able to detect elephants here properly, but you will not be able to detect elephants here properly. So this elephant will not be accurately detected. This elephant is accurately detected, but this elephant is not accurately detected. Can you see that? And that's what's going on here. Okay, so the rules may not explicitly always work. So whatever rules you write may not explicitly always work. And that's exactly where machine learning comes in handy. And it becomes even more difficult when you talk about other kinds of objects. For example, what if I search for snow? What if I search for mountains? What if I search for something? Imagine finding snow. How do you write a series of rules to identify snow? Think about it. Now, we're not even talking about hard. We are saying it's impossible. You can't write code to identify snow. Well, even if you could, what will you say? Like, most likely people will say that, hey, Sign, I think snow is white. So I will write a rule which says that, okay, if something is white in color, but then in that case, what is the difference between snow and clouds? Have you thought about it? Well, in Google Photos, you can do that. You can search for snow and it will show you examples of snow. At the same time, you can search for clouds and it will give you examples of clouds. Now you tell me, have you thought about it? Have you thought about it? How is Google able to differentiate snow from clouds? How is it able to do that? How is it able to do that? Well, difficult, right? You can't just search based on rules in this particular case. So, and that's exactly what machine learning is. And that's exactly where we enter into the formal definition of machine learning. So we say that when the rules are hard, when the rules are unknown, if the rules are known to us, then fine. We can always build a rule-based AI system. I think we are sorted on that, right? We are fairly sorted on that. If the rules are known, then we can build a system. But if the rules are not known, if the rules are hard, if the rules are difficult, most importantly, if we cannot pre-program the rules. And why we cannot do that, friends? Because we ourselves do not know the rules, right? We ourselves do not know the rules. And because we ourselves do not know the rules, we cannot pre-program it. And because we cannot pre-program the rules, we want to make the machine figure out the rules. Why can we not pre-program the rules? Because we don't know it. The rules are hard, the rules are difficult. So we want the machine to learn the rules. So we will simply give the machine lots of input-output combinations. That's the way we understand the idea of ML. So we will give the machine lots and lots of input-output or X-Y combinations. So we will feed the machine lots of inputs and lots of outputs. Input, output, input, output, input, output. Lots of X-Y combinations we will give to the machine. And the machine will learn the patterns based on the data. So whatever input-output combinations I'm giving, the machine will simply learn the patterns. It will simply figure out the rules from the data. And that's the way how we understand the idea of machine learning. Okay. One very important thing would be it is dynamic and it is prone to errors or mistakes. That is one way to look at it. It is dynamic and it is prone to errors or mistakes. So unlike rule-based AI, which is static in nature, rule-based AI is basically static in nature. It is static. So rule-based AI is static in nature. That's one way to look at it. It is static. It's hard-coded. You hard-code the rules. Okay. Machine learning is dynamic because the rules are learned by the machine based on the data that you're providing. And I think the simplest way to understand machine learning is the following example. And you can see this very, very basic way to understand what machine learning is. You're simply giving the machine lots of input-output combinations, 1, 2, 3, 4, 5, 6, 7, 8. And I'm asking you the question that, hey, 9, what? So I am asking you that given this input, what is the predicted output? That's the question I'm posing. But I'm not explicitly stating the rule for you. I'm not explicitly stating the equation for you. I am simply giving you lots of input-output combinations, 1, 2, 3, 4, 5, 6, 7, 8. And you have to learn the patterns based on the input data. So whatever input-output data is given to you, learn the patterns from that. Learn the patterns from that input-output data. And then based on the new X, you try to predict what is the Y. That's the way how we go about it. So 1, 2, 3, 4, 5, 6, 7, 8. We will use a specific machine learning algorithm. Now there is a term called deep learning that you can ignore for now. I'll come back to deep learning later on, right? So we have lots of X-Y combinations or input-output combinations that we have here. Use the algorithm, and based on that you learn the mathematical equation. This is the model or rules or the mathematical function that we are learning. So unlike in rule-based systems where a developer is hard coding that function, it is our responsibility to study the system, gather the requirements, and come up with that function ourselves. In machine learning, the machine is doing that. So the machine is able to use some algorithm. In this case, I think the equation is very simple. I don't think you need anything to figure this out, like 1, 2, 3, 4, 5, 6, 7, 8. You can figure out it is x plus 1, right? Y equal to x plus 1 is a relationship. But this is what these algorithms are doing. So the machine is studying the data. It is using some algorithm, and it is coming up with this particular mathematical model, this machine learning model, which is the rules of the mathematical function. And this process is often referred to as model training. Next time you hear the term model training, what is model training? Model training is the process where you take some data, you use some algorithm, and based on that, you're able to train a machine learning model. You're able to learn the rules, or you're able to learn a mathematical function based on some training data. So that's what we refer to as model training. That's the intuition. And based on whatever patterns we learned, given some new value of x, if x is equal to 9, you want to predict what is the corresponding value of y. You want to now predict what is the corresponding value of y. Okay, so based on the input-output combinations, we will use some algorithm and build a model. Y equal to x plus 1. That is the first thing we will do. And once this particular function is learned, then like given some new value of x, let's say x equal to 9. Now we will do model prediction. So 9 plus 1 is 10. So the model will predict 10. So you can see these are the two important terminologies I wanted to introduce. One is called model training. And we will see in Python later on down the line how it is done. It's typically related to the fit method. We call it fitting the algorithm on your data. It's called model fit. We try to fit. So we try to learn the patterns. It's called model training. This is step number one. And after the model is trained, after the rules are learned, after you learn that equation, the next part is model prediction. So given some new x, you try to predict what is the y. So that's the way how we think intuitively about what machine learning is. And I think a simple way to relate to this would be, take the example of a small kid, a young kid who is just, graduating or attending kindergarten. Okay, you are just entering into the world and you're learning about the world, and you're basically trying to figure out what different types of objects are called. So this is your very first day in kindergarten, imagine, and there's a teacher who is teaching you, right? And imagine it's your first day in kindergarten. You've never seen an apple, you've never seen a guava, you've never seen fruits in your life, and you start learning about everything, from scratch, isn't it? Excuse me. So we all remember the early days when we also studied, right? We had all those chart papers where we used to learn about fruits, bananas, and all that. No, isn't it? That's how it is teaching us. Somebody is basically teaching us, like that, hey, when you have fruits like this, they are called apples. When you have fruits like this, they're called guava. So there's some teacher who is showing us the fruit and who is telling us that this fruit is called an apple. There's some teacher who is showing us another fruit and saying, hey, this fruit is called a guava. And there's some other teacher who is showing us, let's say, a watermelon and saying, hey, this is called a watermelon. So that is how the input-output combinations are given. So the input is nothing but the picture, and the output is nothing but what that fruit is called. So based on the picture, it's called an apple. Based on the picture, it's called a guava. And based on the picture, it's called an apple again. So that's the way how we intuitively think of what what machine learning is. So think of it like humans learn the same way machines learn. So whatever I explained here, machine learning, how machines are learning from the data. You're giving the data and the machine is learning the rules from the data. So in a way, humans are learning the same way. So humans also learn very similarly. You give the data, input, output combination, right? So given this picture, given the size, shape, and color of the fruit, it's called an apple. That's the output. Given this picture, given the size, shape, and color of the fruit, it's called a guava. So that is how we are providing the input and output combinations, and the human is learning the patterns from that. And that's the way we can understand what machine learning based AI is. And again, remember, this all started, the entire conversation started with AI, where we are trying to build intelligent systems. And in our entire conversation so far, we have managed to build intelligent systems in two ways. Point number one, we have managed to build intelligent systems using static rules, where we hard code exactly what we want the systems to do and how we want the systems to do it. That is number one. And number two, we have managed to build intelligent systems using machine learning, where the machine has learned the rules. So number one is using static rules, we are able to build that intelligence. And number two, machines are able to learn the rules. And from those learned rules, it is able to figure out the intelligence. So that is what machine learning based AI is. So next time anybody asks you, what is the difference between AI and ML? Like you should know there's a difference, not just that, we usually see that diagram, no, AI and then superset, subset. I think that's useless stuff, because unless we understand what it is, that Venn diagram is pretty useless. Like, usually in books and articles, they talk about that Venn diagram. There's AI, then there is ML, then there is DL. But what's really important is to have a very classical understanding of where the things evolve from. I hope this initial conversation, was helpful in that regard. All of you can relate to what is what and where the term AI came from and how machine learning even evolved. Why machine learning? That's the first question people should ask. Like, that, hey, I mean, if we were able to design such complex systems, right, operating systems using rules, why did we even need ML? Because we don't know the rules, especially when you venture into unstructured forms of data, especially involving images, audio, video, text, complex forms of data. Writing the rules are extremely hard. Imagine a Google Assistant. You ask something that, hey Google, what is the time today? What is the weather tomorrow? So my Google also fired up now. See how incredibly intelligent these systems are. So based on let me just go and close my Google. So see how intelligent it is. Based on what I ask, it's able to figure out exactly what I ask. So how do you codify this into rules? These are impossible to achieve, right? So the whole idea of speech to text, you can't codify rules and make that happen, right? You can't because every time you say okay Google, every time you say hey Google, you are using a different pitch. Again, my Google fired up. You are using a different pitch, a different frequency, a different tone, and you cannot codify that in rules. You cannot say if and see, you might have seen in the assistants Gemini, you can ask the same question in different ways. You can say, hey, what's the weather today? How is the weather today? Is it sunny today? Is it rainy today? Is it hot today? Is it cold today? Like all the same thing you can ask in 6 different ways. Did you see? I'm ultimately asking about the weather, but I can ask about the weather in hundreds of different ways. Is it possible to hard code it? Is it possible to hard code and say, hey, if the question is asked like this, answer like this? If the question is asked like this, answer like this. So if I were to build a rule-based system, I will have to hard code every single possible combination. Can you see that? Can you imagine how difficult it is? And that's what I'm actually getting at. So you need to realize why not this? Why this is easy to learn, but what is important is realize why not this. When we had this before, why not we do it this way? Because that's why you cannot achieve this way. If you talk about the um, I don't know, the computer vision based systems that we have, like the self-driving cars, which are so popular today. They are all using machine learning. They're able to detect objects using machine learning. You cannot hard code with rules. Imagine traffic lights. Now I get it that traffic lights are always red, yellow, and green, but imagine machines are seeing pictures using pixels, right? When machines are seeing an object in front of it, they are actually seeing that object in front of it using pixels. Now it is impossible to hard code every single possible way a traffic light can look like. There are infinite number of ways a traffic light can look like. A traffic light can look like even a red traffic light, if you look at two different intersections, can be very different from a pixel perspective. The look and feel of the light can be very different. How can you hard code? If can you imagine in that case, to train a self-driving car, we will have to show that self-driving car every single traffic light in the city. Can you imagine how difficult it would be? So can you realize, do you appreciate now why rule-based AI does not work? It's not possible to hard code rules. We cannot. I mean, let's talk about a human. I'll give an example to you. All these self-driving cars, they have ability to detect humans. Let's say a pedestrian is crossing the street, and they can identify pedestrians, right? They should be able to. Like if a self-driving car is driving, and if a pedestrian comes in front of it, they have to brake. They have to brake. Now think about it. How do you write a code to detect a human? I'm going to pause for a second. I'm going to pause for a second. If this was a rule-based AI system, if this was a rule-based AI system, there are 6 billion humans on Earth, maybe 7.5, 8 billion people. If this was a rule-based AI system, you will have to write 8 billion unique rules for 8 billion unique humans. Agreed? Well, I mean, think about it. That's how it's supposed to be, isn't it? Like, because rule-based AI is supposed to be static, flawless. So if you want your self-driving car to identify every single human being on Earth, if they come in front of you, I will pause. You cannot do it, boss. Because people are born, people are dying every day, and every human being is unique. Their contours are different, their pixel body structures are different, their facial expressions are different. You can take a picture of me now, 2 seconds later, I will change. How do you write rules for that? Think about it. See the practical challenges, why rule-based AI does not work. And this is very different from washing machines. Washing machines don't care. The clothes will remain the same. You can have a preset program, it will always work. But you cannot have a preset program to detect humans for self-driving cars. You cannot have it, boss. What preset program will be right? What will be right? Babies can look. There are 500 million babies in the world, right? Maybe young babies, let's say below 4 years. Every baby is different from a pixel perspective because computers will not see babies like how we humans do, right? Computers will see babies like pixels. And from a pixel perspective, every baby is unique. You will have to write 500 million unique pieces of code. Right? I hope everybody is understanding this. And that's exactly the whole idea and the whole inspiration behind studying a slightly different branch of intelligence where machines are learning the rules. And that is exactly what brought us to the original definition by a person named Arthur Samuel. I hope everybody relates to that. Okay. And this is what it is. This is pretty much what we studied so far. I hope everybody's aligned on this. Okay. So this is the field of study that gives computers the ability to learn without explicitly programming them. We are not explicitly defining the rules, but we are just giving them lots and lots of data, input output combinations, and the machine is learning from the data. Okay. I'm going to give you one more, a beautiful animation. This is one of my favorite ones. It really helps the concept stick. Something called teachable machines, and I'm going to go there and help you help you understand this a little better. I'll hold up two objects, right? Let me, I need to close my video actually because I need to turn my video on here. Just give me 1 second. Anybody wants to ask me any questions, you can, okay? Yeah. So I'm gonna give you a very basic example of an image classification system, and we're gonna have two classes here. Number one, we're gonna have the we're gonna have the bottle class, and number two, we're gonna have a phone class. Okay, that's what we will have right now. So there are two classes of objects we have right now, and what I will do, the bottle idea would be to take the bottle and record it in different ways. So So let's just see. Oh, I'm sorry. I think it's actually that's okay. That's okay. I think we can override it. That's okay. Yeah, remove all sample. Let me hold it again. Yeah, sorry. Yeah, look at this. So I want to hold the bottle in different ways, and this is like the input-output combinations which you show to a small kid. Imagine if a kid comes to kindergarten, it's like you teaching the kid how a bottle looks like. The bottle can look out upside down, diagonal, straight, like this. Only the cap is visible. Only the back side is visible. Only the diagonal, the cross section is visible. And these are all examples of bottles. Get it, all of you? This is exactly what I mean by ML. You are giving XY combinations. The picture is given. There are 545 examples of images, and the class is called a bottle. This is how you teach a kid. And same way, I will hold up my phone. I'll hold up my phone. Let's see. I'm going to hold up my phone in different ways, and you can see how we will do this. I'm going to show you. These are all the different ways phones can look like. The screen has lit up. Even the side view, it should know it's a phone. So the S Pen, maybe even the cameras are visible. It should know it's a phone. Maybe the pen is visible. The Samsung logo is visible. Well, actually, that's a wrong thing. I should not do that because then it might create bias. It might think that only if if it's a Samsung, then it's a phone. But that's not how it's supposed to be, right? Can you see? Get the idea? So anyway, so we have got 545 examples of bottles, 550 examples of phones, and now we can train the model. That's how we can relate to machine learning. That's exactly what machine learning is behind the scenes. It will take a while to train. Algorithm is a different idea. We'll come to those concepts later as we go along. But this is just to show you a very simple, dynamic example of exactly what machine learning is. Okay, let's see this. Okay, now it is done. So we can go ahead and I'm going to hold up the phone right now. You can see the model says the phone very clearly. I hold up the bottle. It says the bottle. Can you see? So what is happening on what we did on the left hand side was basically model training. This is model training we did. XY combinations and the patterns were learned. And what's happening here is model prediction. So next time I show a new object, the machine is able to predict what it is. So based on the patterns it learned, I hold the object and it knows exactly. Even if I show just the cap of the bottle, see, it has learned that pattern. Now the interesting part would be, unfortunately, I don't have another bottle. Oh, actually I do. Apparently I have another bottle. Maybe interesting thing will be if I hold this bottle, will it understand? Will it understand? And that's the magical idea of ML. Look at this. Look at the magic. Well, it's not perfect. It's not perfect, but you still see that even if it's a different cap, it's still able to understand the contours of a bottle. Now that's beautiful, isn't it? And that's the beauty of machine learning. The idea of generalization. This is what I meant, right? This is exactly the idea of the traffic lights example that I talked about. It's not possible to show the self-driving car every traffic light in every intersection in the city, or it's not possible to show the self-driving car every single human being, to train it on pedestrians. But you show it one or two examples and it generalizes. So here also I show it one example of a bottle and it understands this is also a bottle. That's the incredible idea. Now, generally, the more examples and the more variety you show, the better the model becomes. That's a general concept. So obviously here I showed 545 examples of the same type of bottle. But if I show examples of 545 different types of bottles, maybe the model will learn a lot better. So that is generally something that we will also have to keep in mind. Okay, yeah. Okay, but I hope the general idea is clear. This initial part of the conversation was to clarify what is AI, what is ML, and I think this is very important, especially when you start on a project. And given there is so much of hype in the domain, everybody thinks they are doing ML. And now even a step further, nobody wants to do machine learning. Everybody wants to do Gen AI. If you go and ask 3-4 of these people what is generative AI and what is ML, none of them even know what it is, right? So, but that's the sad state of affairs today. Generally, how things are happening. But I feel that even from a hiring perspective, even when you go and sit in interviews, it's very important to really appreciate that what these things really are, right? Because next time you have a business use case, companies do not want to know that, okay, that, hey, like, can you build a large language model, make an API call, ask a question, get a response. All that is cool stuff. You get, you copy paste 2 lines of code from GitHub and you are able to achieve it. But hey, I mean, is it even a Gen AI solution? Can we do machine learning using that? So what is very important? Like, what should we do? How do we solution it? Should we solution something using simple rule-based instructions? Should we solution something using machine learning? So that understanding is very, very crucial. All right. So this is the initial part of what I wanted to cover. Any questions before I move on to the next phase? Okay. And also, just to go along, this is the Google Photos one that I discussed. I think everybody knows, even Google, they have these things also, a classical example of ML. So Google has a huge amount of data, and this is something that Google also has done. So they've got a lot of data, and even Google has done something very similar. So they've got lots of pictures of different types of objects. So and based on that, Google also has a trained machine learning model in place. Think of it that way. Okay, and just to show you the architecture or what I'm referring to, just to clarify this once again for all of you. So imagine Google also has different types of objects. So input X is the picture and output Y is the class. So input X is the image. I'll call it IMG. And this is the label. What is that image called? So Google engineers would have collected lots and lots of labeled data, okay, from different sources, and they have lots and lots of different pictures. So pictures like this are elephants. Pictures like this are tigers. Pictures like this are lions. So Google engineers would have also collected lots and lots of this kind of labeled data. That pictures like this are this, pictures like this are this, pictures like this are this, pictures like this are this. They would have collected lots and lots of labeled data like this. And based on that, they have generic examples, not from my pictures. My and your pictures were not initially used for training. Initially, they have used a lot of other generic examples for training. Okay, and this is your input-output combinations. And Google would have used some algorithm. It means a red color. I think it's not visible. They would have used some algorithm. I hope this is clear to all of you. This is data. This is data, and data is the input-output combination. And they will use some algorithm. And based on that, they will build a mathematical model, right? The mathematical model is the rules that they will build. That is, this entire process is called model training. And the initial model would have taken a tremendous amount of time, from Google's perspective. This is called model training. And next time, when you and I, we upload pictures, this is the model, this is the trained model that is already available. And next time when you use your smartphone, when you click a photo, when you go and do that, this is the model training that happened. This is called model training. And next time when you have a new picture, when you have a new photo that you upload on Google Photos, this is like the input X. This is called X new. You have the model, right? Model is that equation, remember? So when you have a new X, you simply plug it into that equation and you predict what is the Y. You have the predicted Y pred, isn't it? So next time when I upload my picture, this is my picture, this is my photo, like as in the photo that I clicked. So when I upload this new photo, Google is able to use this existing model and is able to predict what is that object called. It is called an elephant. And the other thing is that Google is constantly updating that model. Whatever model or whatever relationship it originally learned, is that going to be static? No, it is constantly updating that. So that model, it is constantly getting updated. With new data, with changing data, this model is constantly getting updated. That is one other way to look at it. Okay, so I hope everybody's aligned and everybody's getting a clear picture in terms of what machine learning is. There are tons of applications, but we'll come to that gradually. And if I talk about everything today, it will be overwhelming. But I hope at least the initial ideas are clear to all of you, what it is, okay? So before we proceed along further, any questions? Any questions so far, from the folks? I think this is another way to summarize the jargons a little bit better for everybody. Pretty much what we talked about so far at a very basic level. And what I will do in the next phase of my conversation is talk a little bit about the different types of machine learning, like supervised learning, unsupervised learning, what is regression, what is classification. It pretty much flows, from where we are now. Okay, so this is pretty much where we are. We have data. Data is nothing but the input-output combinations. We will use algorithms to learn the patterns from the data. And based on that, we will build a model. The model is nothing but the rules of the mathematical function. Okay, so we have data. We will use algorithm to learn the patterns from the data, and based on that, we will build the model. That's what it is. Okay. Any questions? Everybody is clear until now? Let me know, guys.
Guys, I think you provide your updates or maybe a feedback or anything that you wanted.
Yeah.
You feel free that to mention that if it is fast paced or
Sure.
if
Sure.
it is if needs to be little maybe I think is it a kind of a slow pace or whatever the you feel that you just please be expressive here. Here it's not a formal educational classroom, okay? I think where somebody is lecturing and we are just watching like that. We wanted you to benefit out of it, 100% it is for you guys. So make sure that you have a very good amount of learning, and you learned in your fashion, and the way that how you transform yourself is ultimately the goal is you carry this knowledge and you apply it and transform your workplace, and so you transform your life, right? Different career roles that you can aspire, and you can anyhow that's actually the uh, the end goal of everyone. So what I request you guys, please, you just tell us that, hey, we are little speed, or we just need this, or maybe sometimes we also make sure that some concepts are not clear. We designed for a classroom of 40 people, may not be same, right? So we have that understanding. So what you need to know, you just come up and ask queries, questions where you are not clear, where there is doubt, or where something that even you say that you have some ideas, because we all here like a collective learners. So make sure we also be ready to take some examples, some ideas from you guys, where you in your domain some kind of things that you have seen that is happened differently, or something you want to share. Please, we welcome that kind of an environment where you be flexible, learn, and make sure the people who are not able to attend because of exams or maybe some reasons, some unavoidable situations, don't worry about it. We will be sharing the recordings, and we ensure that you are thorough on these topics and subject. Okay. uh, any queries, anything that you guys, please raise your hands. You talk to Cyan.
Yeah. Exactly. I think exactly. I completely resonate with Mr. Laksh. Please, guys, feel free. I mean, again, I understand some of you, it's a little diverse audience. Some of you have some knowledge. You already know a bit of machine learning, fair bit of it, whereas some of you are completely beginners. As I said, this is a bit of a level playing field we are trying to create on the first day so that everybody is aligned with the jargons. But yes, please keep asking questions, and don't have to raise your hand. Just shoot. Just unmute and shoot. Just again, you do not have to raise hand. Just unmute yourself and speak. Just speak freely. Yeah.
Yeah.
Actually, I want to know about the models, like my mathematical model, which was used by the software. Is it like something we hard code in it, or it just assumes it makes on its of? I mean, I have used one of the thing in my project, but it says like it's called OpenCV. It says it's pre-trained. So again, you have shown an example of the teachable machine, and it's also like the training part was totally hidden. So I
Well,
want
that
to
is,
know if it's
I know that was an animation, but that is still very much machine learning. So that
okay.
is very much machine learning, where the data is given, the input output combinations are provided. So you have the image and you have the labels that is being given, right? If you relate to teachable machines, this is exactly what we did. We showed the machine lots and lots of examples of pictures, And we also showed the machine lots and lots of examples of what those pictures are called, the picture label combinations. It is like, showing the image is this and the label is this. The image is this, the label is this. And that is what the machine is learning from. The machine is building the relationship. It's learning the relationship from that particular historical data. Okay,
So
make
is it
sense?
like we code about the part where we have tell the machine that you have to follow these kind of models, or
we
it just
we are
assumes?
not exactly. So that is the part where we are simply giving the data. The data is nothing but the original the images and labels that you're providing. The algorithm is basically what we are supplying. So to answer your question, Dhruv, are we telling the machine what to use to learn the pattern? Well, the pattern is something the machine is learning. So think of it like the equation is something the machine is learning. But how is the machine learning that relationship? How is the machine learning that
That's
why is
exactly I
that?
was asking.
That is what is learned by the algorithm. So to answer your question, the algorithm is dictating that. So to
See,
answer
I
your
think
question,
I will
the open, yes, yes,
pick up this question. See, Dhruv, what you need to understand here is, somebody who has invented, there is kind of a mathematical framework. Okay, that is called framework. Within that framework, whatever that you provide, so it will understand in such a way that this is the input and this is your minimum knowledge. See, let's understand, a kindergarten kid and a child, right? So when the moment when you have no idea about anything, if I give you a basket full of fruits to you, by seeing that you will be able to understand the colors, some differentiation. You don't need to know what the name of the colors, but you see something beautiful, all red colors you will be able to group together, all green colors you will group together. This is actually, it is called human intuition. We will say that, without any idea, I mean, we don't even know that. You just give some kids some basket full of some toys. What it will do, it will segregate by colors, some similarities, find out some similarities. First thing, it will see size, bigger size and smaller size. Automatically it will pick up the bigger one, and it will reject the smaller one if you give two things, big and small. So how this happens is, basically, it's an idea that there is a framework which is designed in the machine, that it is a framework where you will be providing an image, and you give some narration, some description, annotation about the image. Now you feed 200 images. What it does, it is associating these two patterns. Okay, if it is an elephant, these are all the things it has to be present. If it is a mobile phone, these are all the things it has to be present. Some association is happening, and it is identifying that the way how our human kids, right, when we give without, need not required to go to schools, just give free. Now what happens when the kids growing? Now the teacher is training over the period, and it is getting the wisdom. You ask a +2 student about a fruit, he will say that this is orange because it is a citric family, and this is actually similar color of orange, but it might be a capricorn. It is not actually a fruit. It is vegetable. How we are able to do it? Because the more understanding, the more the detailing that we were giving to ourselves, so that we will be able to classify. So there are certain frameworks that has been invented already. We are not reinventing anything, and what we were doing within that framework, we will be learning it. That's called applied machine learning. It means already the base has been created for us. On that playground, we will be playing with our inputs and with our outputs. Let's say in Bangalore, you have 1 crore cars. There are a lot of variety of the cars models, and you see 23 minutes it is taking for an inspection of every car. Imagine the size of the labor that has been used for inspecting alone for 1 crore car in a year. at least one service a person is giving for the car. Just imagine the size of the labor. Now, what we do, we will give the samples of all the cars, and we will classify what are all the various defects that we can mark on the body of the car. Let's say the inspector of the car is marking front bonnet, rear trunk, driver side door, and rear pinion door, and front side pinion door, and rear side pinion door. Like that, you will be having a section, and he is actually giving a sample of all dent, damages, broken pieces, missing parts, and paint issues. These are the 5 different defects. You need to sample out as many images, and you need to tell to the machine that these are all the images, and name that this is the model of the car, this is actually the type of the defect. What will happen? A new car that is coming to your garage, it may not have seen, but it is looking like a car, and it is actually having a trunk, and there is a damage in the trunk. It will mark that area. How this happens? By associating your knowledge, the past training that you have provided, your knowledge that you have provided, and the pattern that it has understood. That pattern and the knowledge are the amazing association. This is what happening in the framework, and entirely this entire machine learning is basically with this kind of an intuition only. Even if you go to the maybe I used to say this example, the sugarcane plant, where the farmer is figuring it out, the defects in the growth of the plant. How you will figure it out? By seeing the height of the plant. There's something that the same day all the seeds have been sampled, and the same day they have planted it, and they are giving the same nutrition, but some of the plant is not growing at all. So what you will do, you will pull out all the shortest sugarcane that is along with the crowd, which is actually, let's say all the sugarcane plants are 5 feet, 1 or 2 that is actually a defective plants. Now this is called a kind of an algorithm where the height of a plant has been assessed, and wherever the shortest plant is being identified in the crowd, and they will call it as isolation tree, like a algorithm. So what it does, it is actually the idea is the way how human intuition has been understood, the same intuition mathematically programmed, and with the framework you provide any data to it, and it is understanding the size of the tree, and it is actually identifying the shortest tree and removing them as anomaly. That is called anomaly detection algorithm. All fraud detections in the payment in a bank, if you go, millions of payments are happening in the UPI. How they are able to identify some payments are fraudulent payment? By this isolation tree algorithm. How this intuition is coming? It is just the farmer what he is doing in the sugarcane land. This is actually something that we need to understand. Some brilliance that has come into our plate. Now we are learning that how we use this brilliance, and drive our decisions on a day in and day out, in our business, in our workplace, in our life, right? I think you got the idea now.
So I understood that part, that the frameworks which are generally used, this is like the similar to the human intuition,
Right.
but are all I mean, most of the kinds of all these frameworks or these algorithms are developed because, see, I have a specific case basically. I was doing a project in my final year. It was related to hardware security part. For that, my actually the supervisor wants me to use some kind of machine learning method to basically perform that task.
Okay.
There it was about basically in hardware there's a section called power analysis, which just monitors power consumption, and based on that it actually tries to find out the encryptions, what's happening, or the internal calculation of a device. So
Fantastic.
there's no such actually it's an open competition still out
Yeah.
there. No one is actually doing I mean, there are submissions about it, but no one actually figured out the correct framework to do it. So I was just curious about that framework. Are those things which are already working on, or we can just directly use those
There
frameworks,
would
or we
be
can develop?
there would be definitely some approach to it. What you need to understand, right? No such a kind of a solution that we are seeing today. Be it a classification algorithm or isolation tree, whatever that we were, all the jargons that we were going to name. These are not like today that by overnight somebody has begun it and they got it the Ureha like that. It is actually evolved over a period of time, and even every business problem there are you need to try it out in various different n ways. Okay, we will teach 30 algorithms means 30 factorial of the combinations that you need to try. Finally you will get what you want, because this is how the frameworks basically to solve variety of the problems. It's not just one algorithm or one model that you will try it out. You will you will try to fit the entire universal problems, arena of problems into some algorithms. Some algorithms will do better, some algorithms may not do it well. So what you need to figure it out, some of the problems couldn't be solved. Just imagine, in a runway, some buffaloes have come in between. The autopilot mode has to stop the airplane unless until the model has trained, the vehicle has been trained, for that scenario. It won't, the machine won't understand, right? So it is very much important for us to understand that it is a field that is evolving every now and then. You see today, if I give you a recording of 33 seconds, somebody has created a raga classifier. It will tell what is the Carnatic music, what is the underlying raga it will happen in such a way. They have recorded it, they cleaned up, they identify the noise in the data. You just need to know while you are doing a recording of your music, somebody do coughing, somebody do clapping, right, whispering, all these noises have to be eliminated. So you need to get a fine data set for that to train the machine. And it's like a evolution. You just need to understand that today. I think suno.ai, you just give a text to audio, it is creating music. Just imagine the way that how it is evolving. And the framework, what is underlying the framework, you have some 30-35 algorithms. If you know these algorithms, you mix it up, and it's a Lego block, right? It's all Lego block. You just stack it in some fuzzy way, and you find it out, and you will get a better output and better result, and you can solve anything. Okay.
Okay, got that.
Yeah.
Yeah, great. I think, yeah, if I just have to add one more small part, Dhruv, I think just to, you're somebody who already fairly understands Python and all this, and just to clearly tell you, let's say this is the MNIST data set. I'm sure you would have heard of it. So this is like a digit recognition data set, right? So very popular. A lot of people were asked to write digits on a scale of 0 to 9. And just to share with you the problem statement very quickly. So the input X is the picture, right? And the output Y is basically the label. The label is effectively what that digit is called. Is it a 0, or is it a 1, or is it a 2, or is it a 9? So people were asked to write lots and lots of digits. So people wrote zeros like this. So the image of the 0 was given, and it was said, hey, it's called a 0. Some people write zeros like this also, right? And I know they look the same, but from a pixel perspective, they're very different, right? So this is how you show the machine lots and lots of examples of images, and you say what those pictures are called. So this is like a 7. And remember, some people also write 7 like this. This is also a 7. So this is the way how you provide your data. This is your input-output combination, Dhruv. And you are using different types of algorithms. And this algorithm part is the mathematical part. So just to clarify, how is the machine learning the associations between the X and the Y? Coming back to your original question, what you asked, that's fine. We have the data, that is fine. How is the machine learning the association between the input and the output? That is the part that Mr. Lux was mentioning, part of the mathematical frameworks. That's where the algorithms are there. There are different algorithms that are there, right? And there are different algorithms that are already available in Python. You mentioned OpenCV at the start of your question. OpenCV also has a lot of built-in algorithms. Now remember, these algorithms are already built in. It is not something that we'll be creating. So these algorithms are already built in. So imagine at a very high level, Dhruv, if I give you, let's say there are two algorithms available. I've got algorithm 1 and algorithm 2. I'm avoiding technical terms right now. There are different algorithms that are available. So so you have two algorithms available. So you will try algorithm 1, build a model. You will try algorithm 2, build a model, and you will see which particular model is able to classify more effectively. Makes sense? So the algorithm is where the the mathematical frameworks are defined. Okay, and we will from an implementation perspective, purely from an implementation and engineering perspective, we will try different frameworks and different algorithms and see that which algorithm is able to build a better quality model. That's the intuition, right? I hope this is this is absolutely clear to you, right? Makes sense, Laksh? Sorry, Dhruv, yeah.
Yeah, got it.
And from a code perspective, if you see, just purely from a code perspective, I wanted to show this also to you so that you relate to it. This is like your input output. Again, this is training and all that you can ignore. This is how that Python part of the code actually looks like. You can see that dt.fit xtrain ytrain. So we are using a specific algorithm called logistic regression. Again, these are things we will talk about in detail in the remainder of our course, right? But this is how it kind of looks like. So we have the data, we have the XY combination, and we will simply use an algorithm called logistic regression, and we will learn the patterns. Now, instead of logistic, you can use a different algorithm also, right? And that's why I mentioned at the beginning that data, algorithm, model. If you use a different algorithm, you will end up getting a different model. If we use a different algorithm, we will end up getting a different model. So data, algorithm, and model.
Got it.
Is it okay? Does
Yeah.
it make sense? Okay,
Yeah.
great. Okay, wonderful.
Okay, thank you, guys. I think this is a wonderful start. Actually, as I could say that really I thank everyone who has successfully made it today. And I wanted you guys keep going and make sure that on time, we have presented today. Please, this journey has to continue, and we have to make this make you guys successful. So that's our important our side goal, and you have to make this learning and transformation successful. And we would also hear from you that they can have a more collaborations. And also, as one of the things that Dhruv has raised it here, any such a kind of an idea that you want that to discuss about it, I for the first thing is you just it is good that you have brought it up, you talk about it. And if we could help you on our side, we will be definitely willing to help you, and we will team up. And we have very good amount of mentors for that, a specific domain. As I said, it's a power domain, electrical, electronics, pharmaceutical, chemical engineering. We have mentors for that. I will put across you separately for those discussions. And where they can already somebody in the in this planet, they might have already explored that kind of a problem. Means it is easy for us to replicate it, right? So we don't need to reinvent the wheel. Yeah, we will get on that. We will definitely spend some time, some meaningful discussion, and keep going, keep doing. Yeah. Okay, I think we have no questions at this point of time, Sayan.
Yeah, sure.
Yeah,
Absolutely.
we will connect again, and you just let us know. Maybe a weekly schedule would be fantastic, so that based
Sure.
on your availability, and most of the team. I mean, most of the people are like college students and workers.
Yeah.
So either in the I prefer in the evening. So that in the morning they might be busy, preparing, and stuff like that. We will connect we will connect on weekdays on the evening. On weekends, up to you. You just based on your availability, and
Of
you
course.
just you directly
I
put
think
your
I think one good thing is that the holiday season will happen for most of the folks now, especially
exactly.
Christmas
Yeah, yeah,
holiday. So this
yeah,
is a very good period where we can have a continuous 2 to 3 week stretch where I will continuously do classes.
yeah,
That's
yeah.
my plan.
Fantastic.
You
Yeah,
know, so so I think yeah, absolutely. I think especially starting, I guess. Yeah, I think mostly we will come to the schedule anyways. The weekend class around, I think we can build a rhythm around 10:30.
yeah.
I think this is a good rhythm. I think so people will also have a discipline that okay, this is the time when we meet.
Right.
Um, I think weekend morning is a good time.
Correct.
Uh, Everyone's mostly fine with this. Weekdays, we will see. I think that's a that we'll keep it a little flexible right now. So
Yeah.
and let's see. I think we're just starting out this week. So I think some people who are not part of this session today, and mostly tomorrow, if everyone joins, fine. But uh, over the course of the next week, some of these folks can look at the recordings
Great.
and I think maybe for the first two classes we can keep it for the weekend and then we can start. I think uh, that's one of the ways how we can do probably. Yeah,
Yeah. Right. Yeah, I
yeah,
think
yeah,
that's really an amazing point here, because the people who
yeah.
over we will see
Because
the
my point is if we meet again from Monday to Friday, next 5 days we would have completed 7 classes, and some of the folks who are just entering into the rhythm, they might miss out. So my thing is let's start with the weekend,
right.
at least the first 4 weekends.
Right.
This Saturday, Sunday, again we meet next Saturday, Sunday, and then we will start to alternate on the weekdays.
So
I think we can build that rhythm that way. I think it will work
yeah,
work
they
well.
also
Yeah,
need a time for maybe doing the practical side of
yeah,
it, and
yeah.
might be that is the right way of doing it, is what I'm thinking. Yeah.
Right, right.
Okay.
And guys, also initially it will be, as I said, you know, people are coming from different backgrounds. Obviously, I think from a learning perspective, some of you are. I wanted to stress again that this is going to be implementation. I think this is also a question that Dhruv asked, like, what are the mathematical frameworks? Like, what is important and what we are really trying to do here is to really help you implement things, right? Uh, Mr. Lux also touched on this a while back that many of these algorithms have already been created, which is why if you look at the world of AI, there are two distinctly different you know tracks that go. One is AI researchers. Even in many job descriptions, you will find it. So there is one track which goes into AI research, and there is one track that goes into AI engineers. So AI engineering is distinctly a different field. Now, unfortunately, what happens is the two things are confused and combined in different ways. I think a large part of this has got to do with so many courses and all this that's going on YouTube and all that. People mix and match both the things. But please understand, AI research is very different. AI engineering is very different. We are primarily focusing on the engineering aspect, where we are trying to use existing frameworks and we are trying to solve business problems. Because the research part is where you're entering into the mathematical details of the algorithms and you're trying to come up with newer algos. That's AI research. That's mostly into PhDs and the other stuff. But what we are really trying to focus is the engineering aspect, where you're using and where the vast majority of everything's going on. All the action is in AI right now. It's in engineering. Everybody, all major companies are solving engineering problems because research problems are in academia, right? All the open source frameworks that we will study, like scikit-learn and all these algorithms that we will study, at least in the initial part of our course, all these are, most of them have come out of academia from AI researchers. And then the engineers, enterprises are using existing frameworks, existing algorithms, and they are solving business problems, which is what our focus is. Our focus is on the AI engineering and the implementation bit. I just wanted to clarify that part. And a lot of times in this course, you might have this question because, and again, part of this has to do with so much of content that is floating around the internet. Like people talk about maths and statistics, and do I need to know this and that? Again, be very very clear about the objectives. One is AI research, and one is AI engineering. Right? The focus is on engineering. We are trying to solve business problems using existing stuff, like pretty much like what Dhruv did. Like he showed a nice real world demo that hey, how do we use existing stuff and how do we actually build a detection system? That is actually what we are trying to achieve. We're not going to make you sit with a textbook and study calculus here, right? So I think that difference is very important to understand. Okay, yeah, okay, great. That's all from my side, Mr. Luck. Yeah, Thank you. Thank you, guys. I think that's all from my side. I'll see you tomorrow, same time. Okay. And looking forward, we'll continue the journey and we will pretty much continue the introduction process here. Some more examples. So tomorrow will be a lot more example oriented. We will see the machine learning framework in a little bit more detail tomorrow, how it is done. And we will specifically enter into regression, classification, and if time permits, we'll at least see a couple of code examples in tomorrow's session. That's the plan. Okay. All right.
Thanks a lot.
Thank you, everybody.
Thanks for everyone. Yeah.